Hey guys, my name is Pablo. Welcome to my next video in C++ series. In this video we will learn how an executable file is created from C++ code. In previous lesson we learned how to create first project in Visual Studio 2019 and created our first C++ program. And to run the program we just clicked Start Without Debugging button, but I didn't really explain what happens when we click this button. In very first video, when we were downloading Visual Studio 2019 and installing this program, I said that in Visual Studio there are different development tools that we are going to use, and we'll talk about them later. Some of these tools participate in the process of creation of an executable file from C++ code, so we'll talk about them in this video. Firstly, let's note that a computer understands only the machine code that consists of ones and zeros. A computer doesn't understand C++ or Python or any other programming language's code. All the code that was written using certain programming language should be translated into the machine code. The process of translation into the machine code differs depending on programming language, but the main idea and the purpose of such a translation is exactly the same: to convert the code written in certain programming language into the machine code, because that's the only one representation of information that computer understands. Let's consider all steps that should be performed to create an executable file from C++ code. Here is a schema that shows this process, and we'll talk about each step of this process more detailed. The first step is preprocessing. In previous lesson we created a text file called main.cpp and wrote some C++ code. A text file that contains the code written using certain programming language, in our case C++, is called a source file. We talked about the command include_string previously, and mentioned that by using this command we include an external C++ code that we want to use in our project. All commands that start with hash symbol are called preprocessor directives, and they are executed at preprocessing step. We will take an example of preprocess directive, the command include, as it's most widely used. What it really does is just copies of the content of certain file, in our case it's iostream file, into source code. After preprocessing step, we should have a new file with all preprocessor directives executed. Let's view a file that is created after preprocessing step. By default, Visual Studio doesn't show this file. We have to go to Project Configurations and say Visual Studio to show file after preprocessing. Let's right-click, Properties. Here we need preprocessor configurations and line preprocessor to a file. Let's change this line to yes. Click OK. Now let's run our project. By the way, when we go to debug, start without debugging, we both build our project and run an executable. But for now we only need to build project, so let's choose only to build and go to build and build solution. At the end of this video you will know what really happens when we press build and start button. We have successfully built our project. Let's go to project files and find the file that was generated after preprocessing. Open folder in File Explorer. Here we need a debug folder, and we can see the file with I extension is our file that was generated after preprocessing step. It takes 1.5 megabytes, but we have written only a few lines of code. Why this file is so huge? Let's take a look at this file. We need the end of the file. As you can see, we have a huge amount of lines in this file, and at the really end, we have our code written. As I mentioned before, preprocessor directive include just copies and pastes all the content of the file. There is a lot of code in iostream file, and preprocessor directive just pasted all this information into our C++ source file. After preprocessing step, we have full C++ source code, and this file is ready to be an input for the next step, compilation. At this step, we will talk about one of Visual Studio 2019 components, C++ compiler. C++, just like other languages, has a set of rules that the programmer should follow. Follow the syntax of C++. We give a compiler our full C++ source file after preprocessing step, and compiler checks whether the file has some syntax errors or not. If it has some, we get a compilation error. Compiler tells us that in certain line of code we haven't followed C++ rules. We must fix this error and then give a compiler a new file. In case there are no compilation errors, a compiler produces an object file. What an object file is, we'll talk a little bit later. Now let's have an example of compilation. We don't need to view a file after the preprocessor step anymore. That's why I will return to the default preprocessor settings. Let's have an example of compilation. Previously, when we were building our project, we had no compilation errors because we've written everything correct. Let's have a mistake in our source code. And try to build our project again. Now a compiler says that there is an error in our source code at certain line. It means that a compiler is unable to produce an object file. So we need to fix this error and then give a compiler this file again. Let's try to build our project again. We have no compilation errors and it is said that our project is successfully built. Let's take a look at the object file. As you can see, it's not really a human readable text in this file, but an object file contains an object code. It's a machine code that consists of ones and zeros, and this code computer understands, so it's a binary representation of full source C++ file. In object files, there are a bunch of other stuff, but we won't talk about this right now. Let's concentrate on the fact that after a compiler produced an object file, we finally have a code that a computer understands. And for every source file, an object file is created. In our case, we have only one such a file, but if we had two, compiler would produce two object files. Now we need an instrument that will link all these object files that we have after the compilation step into one executable file. As soon as we receive an executable file, we can put the code of our program into the memory, and central processing unit will read and execute commands of our program from random access memory one by one. But we will talk about this process more detailed further in this video. The instrument that links all object files into an executable file is called a linker. Let's talk for a while how linker works. In our program we have the main function. I mentioned that's an entry point of our program. When we start to execute commands of this function, the address of this function is stored somewhere in random access memory. To start the execution of this function, we have to receive not the name of this function, but the actual address in random access memory that is associated with this name. After compilation step, in object file we still have the name of the function, but not the address. When we learn functions and variables, you will understand this information better. But for now, let's memorize that after compilation step, there are no addresses of memory in an object file. For example, in our object file, we have just the name of the main function, not its address. Let's imagine we have another function. We'll call this function func and give just a declaration to such a function. What we have done is we just told the compiler that we are going to use this function, but we haven't told what commands this function is executing. Now let's use this function in the following way. For compiler, it's enough to mention that we are going to use certain C++ code, and he just checks whether code with such names exists. He does not check whether the actual commands are present or not. We will learn functions and the way they work in further videos. We just need them for understanding the main idea how linker works. Now, if we try to build our project, we should get a linker error. By the way, all linker errors start with a linker word, while all compilation errors start with C letter. And regard a linker error, as we haven't provided our function with some commands, and the linker says he can't find the implementation of this function. We haven't written what exactly our function does. We have written that we are going to use this function, but when we tried to use it, linker started to search for commands of this function and he failed, because there are no commands. To fix this error, we should add the body to our function, which consists of certain commands that our function will execute. The body is added in the following way. And let's add some command that prints some information. Let's try to build our project. And now we have no linker errors. I guess now you understand that when we use preprocessor directive include, we just added the main information about the ifstream file. But the actual commands, how for example stdcout works, are added at linking stage. There are static and dynamic libraries. Now let's talk only about static. Such a library is kind of set of object files that are stored together in one file. At linking stage, we add the actual instructions what a computer should do, while at compilation step, we just need to give the main information about our C++ code. To cut a long story short, at linking stage, we take all of the object files of our project, take libraries that in fact are a set of object files to replace names in object files with addresses in memory where commands will be stored, and afterwards have an executable file. In fact, there is some other information in an executable file except commands of our program. For example, the amount of memory that should be allocated for our program, maybe some debug information, and some others. But we'll not talk about this right now, really detailed. As soon as we have an executable file after linking stage, this file is given to a loader. A loader is a component of operating system that prepares a program for an execution. It reads the content of an executable file and then stores the instructions he read into random access memory and performs some other preparatory tasks that are required in order to prepare the executable for running. As soon as loader finishes his job, the program is ready to be executed. Job of loader takes a few seconds, but in fact it really depends on the size of the program that needs to be run. Now you understand what happens when we press build button. First three steps happen: preprocessing, compilation, and linking. And when we click start without debugging button, happen the next steps: preprocessing, compilation, linking, and the job of loader. By the way, here we choose run without debugger button. Debugger is an extremely important instrument for every developer. Without any doubt, we will have a tutorial about debugger in one of the next videos. Let's take a look where an executable file of our project is located. Visual Studio has some weird default folders configuration, but nevertheless we will find our executable. Let's run our application. We have a really small application and it finishes its job really quickly. We haven't even noticed that it was executing. Let's make our program wait us to enter some symbol by adding the following command. Now we have to build our project again. And now let's take a look at our executable once again. This command waits us to enter some symbols and finishes after pressing enter button. So now you can see where an executable of Visual Studio project is located. After this lesson, you know all steps how an executable file is created from C++ code and what happens after the creation of this file. Let's take a look at our schema for the last time. Firstly, we have files with source code that are given to a preprocessor. Preprocessor executes all preprocessor directives and produces full source code files that are given to a compiler. Compiler checks C++ syntax in each full source code file, and if there are no errors, produces object files that are given to a linker. Linker replaces all references to a memory with addresses in object files as library code and produces an executable. Executable is given to a loader, and loader loads the code of a program and its data into random access memory, gives central processing unit the address of an entry point of our program. Afterwards, central processing unit starts executing our program, starting with the very first command given by a loader. Thanks for watching. If this video was useful for you, please like it. Of course, don't forget to subscribe to my channel. Love you. See you in the next video.